Hey guys, Mr. McKinney here, just going through the practice on the definition of the derivative. Alright, so on this first problem, it asks us two questions. Is it continuous and is it differentiable? So let's start with continuous first. So there's three things that have to be true in order for it to be continuous. The limit has to exist, the function has to exist, and those two things have to be finite and equal to each other. So let's go through those three pieces. Alright, so let's start with the function existing. So f of 1, does the function exist? Well, it's defined when x is equal to 1 here. So I'm going to use the top equation. 2 times 1 minus 1, 2 minus 1 would be 1. So f of 1 is 1. Alright, so now I need to find out the limit as x approaches 1 of f of x. Now in order for that limit to exist, the limit coming from the left and the right have to be the same. So let's look at the two sides of that limit. So the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right of f of x. So from the left, I'd want to use this top equation. So 2 times 1 minus 1 equals 1 again. And then for this bottom one, I would say the square root of 1, which is 1. Since these two pieces are the same, that means that the limit as x approaches 1 of f of x is equal to 1. And then since f of 1 is equal to the limit as x approaches 1 of f of x, which is equal to 1, that means that it is continuous. Now, on a test, what we're looking for is the limit notation from both sides to show that they're equal, and then showing that the limit is equal to the value of the function. So this is the type of work you would be expected to show on a test. Now let's look at differentiable. So to find out if a function is differentiable, two things need to be true. So in order to be differentiable, number one, it has to be continuous, which is what we showed in the first slide. So we know that's true. And then number two, the slope coming from the left has to equal the slope coming from the right. And the way to find the slope is to look at the derivative, because the derivative tells you the instantaneous rate of change. Now we've talked about two formulas for the derivative. Since we know the specific point that we want the derivative at, we want to know what the derivative is at 1, coming from the left and coming from the right, we can use this version of the formula. The limit as x approaches a of f of x minus f of a over x minus a. You can also use the limit as h approaches 0 formula for both of these and find the rule and then plug in 1, but I think it's going to be a little bit easier since we already know what point we want to know the slope at to just jump to this formula. You can use this formula when you're just trying to find the instantaneous rate of change or the slope or the derivative at a specific point, in this case when x is 1. So let's look at the left side first. The limit as x approaches 1 from the left. So f of x minus f of 1 over x minus 1. So then we would say that this is the limit as x approaches 1 from the left. From the left, we're going to be using the equation 2x minus 1. And then f of 1 we found in the previous slide was 1 over x minus 1. So this would be the limit as x approaches 1 from the left of 2x minus 2 over x minus 1, which would be the limit as x approaches 1 from the left of 2 times x minus 1 over x minus 1, which now I can actually plug in 1 after I cancel that factor out because there's nowhere to plug it in anymore, and the answer is 2. So we would say the limit as x approaches 1 from the left of f prime of x is equal to 2. So the slope coming from the left side, f prime is another way of saying the slope. So approaching 1 from the left is equal to 2. Now, we could have skipped all this work and just said this is a linear function with a slope of 2, so at all times the instantaneous rate of change or the derivative is equal to 2. but I wanted to show you the work. All right, now let's look at the derivative or the slope coming from the right side. So the limit as x approaches 1 from the right side. And again, I'm going to be doing f of x minus f of 1 over x minus 1. So this would be the limit as x approaches 1 from the right side. F of x coming from the right side is the square root of x. It's still minus 1 because my f of 1 was still 1 over x minus 1. If I plug in 1 right now, I get 0 over 0, so I have to simplify. Now, to get rid of the roots, I'm going to multiply the top and the bottom by the conjugate, so the square root of x plus 1. So that's going to give me the limit as x approaches 1 from the right. Square root of x times square root of x is x. The middle terms cancel out, minus 1, over x minus 1 times the square root of x plus 1. Notice that on these conjugate problems, you're usually not going to want to multiply out the denominator, or the one that's not a conjugate. So here I can cancel out the x minus 1s, leaving me with a 1 on top. And now I am allowed to plug in the 1. So this becomes 1 over the square root of 1 plus 1. Square root of 1 is 1, so 1/2. So the limit as x approaches 1 from the right of f prime of x is 1/2. So this is like saying my right-hand slope, and this is like saying my left-hand slope. Since these two are not equal to each other, this is not differentiable. And this is the type of work that you would want to show. You would want to show the work for calculating the slope at each of them, and then show that they're not equal to each other. All right, let's look at this next one. So f of x is x squared. We want to find an equation for f prime of x, graph them both on the same graph, and then write a summary. I'm more just going to talk about it instead of trying to write it out. So to find an equation for f prime of x, that's where you're going to use the instantaneous rate of change formula, or the definition of the derivative, because those are the same thing. So f prime of x is going to be the limit as h approaches 0, f of x plus h. So instead of x squared, it's going to be x plus h squared minus f of x is just x squared over h. If I plugged in 0 right now, I'd get x squared minus x squared. That'd be 0 over 0. So I need to do some work first. So f prime of x equals the limit as h approaches 0. If I multiply this out, I'd get x squared plus 2xh plus h squared. Make sure you don't forget that middle term. Minus x squared over h. The x squareds could cancel. If I plug in h as 0, I'd still get 0 over 0. So I need to get rid of this h on the bottom with the h's that are on top. So limit as h approaches 0. I'm going to factor the h out on top, make it 2x plus h over h. Now I can cancel those h's out. So f prime of x, I can plug in h as 0, and the rule for the derivative is 2x. And now that you guys have watched the video on the power rule, you could have just done that. But since it says definition of the derivative, if you see those keywords, definition of the derivative, that tells you that you need to show this work. All right, so f of x, let's do in blue. So f of x is x squared, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So there's x squared. F prime of x, which was 2x, would be a linear function. And the main things you want to be noticing here is when the original function flattens out here, the derivative is equal to 0. When the original function is decreasing, the derivative is negative. Note that it's not decreasing, it's negative. When the original function is increasing, the derivative is positive. So that's the main thing you guys should be taking away. If the original function is decreasing, derivative is negative. Original function is increasing, derivative is positive. And if the original function has a max or a min, then the derivative is 0. All right, last one. So we're given a function and asked to find the derivative at a point. Since it wants it at a point, I'm allowed to use this formula. The limit as x approaches a of f of x minus f of a over x minus a. I can always use the other one and find the rule and then plug in 1. But usually if you're finding the slope at a point, this formula is going to be a little bit easier, a little bit less work. All right, so limit as x approaches a, f of x is my function. In this case, it's g of x, but 2x cubed minus 8x minus, and then f of a would be f of 1. In this case, it's really g of 1, which would be 2 times 1 cubed minus 8 times 1. 2 minus 8 would be negative 6. Two negatives here are going to turn into a positive 6. And then x minus a still on the bottom. Now, if I were to plug in a right now, I would get, I can plug in a. This should be limit as x approaches 1. And this a value should be 1 because this was f of 1. Now, if I plugged in 1 right now, I'd have 0 on the bottom, and I would also have 0 on the top. I'm at school if you guys didn't notice. So those would be 0 over 0, so I need to get rid of this. I need to factor the top. It's a cubic, so it's not obvious how to factor it. But since it's 0 over 0, that means that you will be able to divide it out evenly. So I'm going to use synthetic division. 2, 0, negative 8. Note that this becomes a positive 6. And then I use the opposite sign here on the outside. First number comes straight down. 0 plus 2 is 2. Add those, negative 6. And that's 0. And I knew it was going to be 0. Then I have my remainder constant x squared. What this work meant is that I can factor the top to be 2x squared plus 2x minus 6 times x minus 1. That's what I was doing over there. If you need help on that, come to tutorials. Or talk to your Algebra 2 or Pre-Cal teacher. Now I can cancel these factors out, so I'm not going to be dividing by 0 anymore. So now I can actually plug in 1. So if I plug in 1, that's going to be 2 plus 2 minus 6, which is negative 2. So g prime of 1 is negative 2. And this is the work that you would have been required to show. Now, you don't necessarily have to show this work. However you factor it is up to you. There's more than one way to do that. But you would need to figure out a way to factor this. All right, hope this helps.